All right. Today is the 16th of April, 2026. We're doing POTD. Oh, no. There we go. Oh, I've done this one before. Wait, what? Why is my mouse not doing things? Whoa. What is happening? There. Whoa. 2025, last year. Damn. Okay, we can do it again. You're given a circular. Okay, so yes. So yesterday's problem was circular stuff. Today's problem is also circular stuff. You're given circular array nums and an array queries. For each query, you have to find the following: the minimum distance between the element at index queries I. For each query, for the ith query, you have to find the following: the minimum distance between the element at index queries and any other index j in the circular array, where nums at j is equal to nums at that particular query value. If no index exists, the answer for the query should be -1. Return the array answer of the same size as queries, where answer I represents the results from query. Okay, so I don't really understand what just happened. Let me read this. So you have this nums and you have 3 queries, 0, 3, and 5. So query 0 was saying find the minimum distance as well, the minimum distance between the index 0 and any other index such that the nums are the same. So here, where is the close? So for the query 0, that means we look at index 0 and we ask, okay, that value is 1. Where is the closest one to this one? And the answer is this one with the distance of 2. So we put 2. 3, 0, 1, 2, 3. We're asking, okay, given this 4, where is the closest other 4? There is no other 4, so you give -1. And then 5, 0, 1, 2, 3, 4, 5. You have a 3. Where is the closest 3? It's over here, which is either 1, 2, 3, 4 away, or 1, 2, 3 away, because it's circular, so you can spill off the array and come back around. So 3. Okay. The example has helped. And here, I guess the idea is because you have all different values, there's no duplicates, every query should give -1, because for index 0, there is no other 1 to find, so you give a result of -1, etc., etc. Okay, this is this isn't necessarily easy. Let me get my OneNote. Is XP Pen open? Yeah. Okay. All right. So this is POTD 3488. Okay. So we'll take one of the examples. I'll take the first example, look pretty good. So nums is 1314, 1314, 132, and queries is equal to 035. Considering that we need to build my answer array, like my answer needs to have 3 elements in it in this case, because it needs to be the same size as queries, because the answer of each query. Probably makes sense to iterate through each query. So for queuing queries, you get the queue value. I guess your like target or whatever is equal to nums at queue, like you're getting, and then it becomes a question of find the closest instance of the target value, not including position q. So this is the part that's hard. Finding the other We get the target and we find the other there was that find the other key. There was that idea where what if we because there was another problem where we like made contiguous arrays out of non-contiguous arrays. I don't remember exactly. I might be able to find it. I'll do it later. I don't know. But what if we have a structure as follows? We have a hash table, and you have the keys are each target you could have. So in this case, 1, 2, 3, and 4. And the values for each key is the positions where that target exists. So you have so I'll label the indices 0, 1, 2, 3, 4, 5, and 6. So target 1 exists at index 0, index 2, and index 4. Target 2 exists at index 6 only. Target 3 exists at 1 and 5, and target 4 exists at index 2 only. So what does this do? So if this is my structure, what this really means we look up HT at the target and set it to be equal to so look up the position list, which is equal to the HT at the target. If the length of this position list is less than 2, right? Like probably will be 1, but if there's not at least 2 values, yeah, we can say if it's equal to 1, I think it's fine. Then report -1. So after we've done the construction, we iterate through. So this is like pre-processing this part. After we make this HT construction, we go through this loop. We look for position list. If the length of position list is equal to 1, then that means the instance that we have found, for example, the 4, that's the only instance of 4 that exists. So there's no point in trying to look for, there's no point in trying to look for another instance of 4. So report -1. Otherwise, we have to find where the position exists. I have an idea, but I don't know if it makes any sense. I kind of want to make a second hash table. Hash table where the keys are num positions. So 0, 1, 2, 3, 4, 5, 6. And they map to, in fact, this doesn't have to be a hash, this could just be a list actually, because the keys are just indices. They map to the index that they exist in their position. So if I was to label the indices of each individual list, this would be 0, 1, 2, this would be 0, this would be 0, 1, and this would be 0. So, this green 0 here would map to index 0. The 1 over here would map to 0. The 2 over here would map to 0. The 3, the green 3, wait, what? Why is there no 3? Oh, I think I messed up. 4 this should say 3. Because target 4 has position 3. So index 3 has a position 0. Index 4 has a position 2. Has an index 2. I should say, so the green are like the positions. Red is like target. Green is like their positions in the nums array. So your nums position. And the black is like your HT index or whatever. red HT. So yeah, this actually won't be a hash table. This will be like an index lookup list. It'll be a list. Yeah, 4 maps to 2, 5 maps to 1, 6 maps to 0. Okay, so the reason I have this is the following. If the length of position list is not equal to 2 at least, if it's equal to 1, then report -1. Otherwise, we need to find where Q is in the position list. What do I mean by that? So for the query 0, we look at this index. We know the target is 1. Maybe I'll no. Let me do 5. Let me look at query 5. We know that 0, 1, 2, 3, 4, 5. Right. The target is 3, so we need the positions of 3. Okay, which are these positions? We know that the 3s are at index 1 and index 5. That's what this is telling us. And then we need to look for where is the 3? Which 3 is like our query, right? Is it the 1 or is it the 5? It's the 5. It's this one, right? But how do we find that really easily? Well, this guy will tell us that index 5 maps to index 1. So this 3 is the one that is our query and therefore shouldn't be a 3 we consider. Then we look ahead and we look behind. So via index lookup. I don't know if this makes any sense. It makes sense to me, but I think the colors are helping me. I'll write it out a bit more formally in a second. So find where Q is in position list via index lookup, and we'll call this index I. Look at the position list at I plus 1, and we have to mod as well, mod with the length of the position list in case we have to wrap around. So to get from 5 to, we look ahead, it's 1. Get rid of all this. So in order to get from 5 to index 1, it would be 5, given that the length of nums is 6, nums.length is equal to 7, sorry, not 6. 1, 2, 3, 4, 5, 6, 7, yeah. From 5 to 1, what do I have to do? How do I calculate distance really easily? If it's smaller, then it would be 1, 2, 3, 5. Is it just 1 minus 5 mod with 7? Does that work? I think so, yeah, because you get minus 4 and then mod it with 7, you get 3. Minus 1, 2. Yeah. Okay. If how am I saying this? Look at position list, look at 1 past the position list, and get the distance. Get the right side distance by going to the right. So going from index 5 to index 1, going to the right. 1, 2, 3. So we'll call this V. So it should be V minus I? No. V minus Q, because Q refers to the 5. Q is here. And V would be set to here. Q is here. I refers to over here. I is the black. Okay. And now I'm trying to get somewhere. Q is here. We get this index. So V is the green value here. V is the green. I is the black. V is the green. And then you do V minus I, mod it with N. Damn it, Q. V minus Q. Because that's the original position of the target, and that's the new position of the target. That's like the closest position of the target. Mod with N. And then also look at V equals position list to the right, I minus 1. I have to mod again. So like so either it's, if I is 1, then it goes to 0, no problem. If it's 1, if you're over here, if the target is, if the query has a value of 1, so Q is here, then we're looking at this. We know it's at index 0 within position list. So we do 0 minus 1, mod it with 2, that'll give you back to 1, that should be fine, yeah. Mod it with the length of position list, and then do Q, because Q is bigger, minus V mod N. And the idea is, in the case where you're over here, you go 1, 2, 3. 1, 2, 3. So I get 1, 2, 3, 4. But in the case we're going to the right, or to the left, it should be, this is your V, this is your Q. So Q minus V would be mod minus 5, it's minus 4. You mod it with 7, you get 3, which is what we want. I think this is right. Okay, it's just, it's really poorly. I wrote it really poorly, so it makes 0 sense. But I think this will work. So, first things first, I need to use better naming, because HT I think is a bit dumb. So num's length is equal to the length of nums. Start with that. We'll say answer is equal to 0 times the length of queries, just so we can set up the answer array, and then find where Q is in the position list. So construct the HT. So what is HT? HT tells us target to positions is equal to this guy. Can I have is it from collections import default dict? Default dict this? How to use default dict. Still not fully stuck yet. It's something like you can list. You put you put list. Okay. For nums, so I need each position. For I n in enumerate nums, say num, target two positions at num dot append this position. So that will be nice and sorted. And then so that's target to positions, and I also need position to pos index equals that. Will be 0 for in range, oh wait, I don't need to do all this, times num's len. So we're making an array. So we're gonna construct both of these at once. So for I num in enumerate nums, we're going to say what positions, where this target is positioned, and also the length of target to positions at that num minus 1 is the index for that position I. So positions to pos index at I is equal to this. So we're saying it's a way of mapping the location of a particular nums index, the green index, nums index, to the position list, these red lists, those positions. Okay, I don't know if that made sense. Anyway. Now, hopefully that's enough setup. For Q in queries, I need to enumerate so I can access the answer array. Maybe I'll say Q index to make it more obvious. So target is equal to nums at the query. Maybe I'll call it query. Target is equal to nums at query if the length of target to positions at target is less than or equal to 1. I think it should be equal to 1 in this case, but whatever. Answer at the Q index we can report is -1. Otherwise, we have to find position list is equal to target here. So we have the list of all of the positions where that particular target exists. Now, which particular target are we using with this query? Well, it's the one pos list index is equal to this guy at Q, at query. No, yes, at query. Given a particular index, it tells us where that index exists in the particular position list it is in. So for example, index 5, nums index 5, exists at index 1 in the position list. Thus, 5 maps to 1. It's probably the most sense I've made so far. So therefore, we know the position list index from this array thing. And then left target, no, right, we'll do right target. Right target we get by going to the right is equal to the position list at the position list index plus 1, going to the right by 1, and then modding by the length of the position list in case we spill past the right side. Let's go back around. And so the right steps, so right target position, I should call it. Right? Yes, because position list refers to, yeah, okay. Right steps, we said, was the right target position minus the query, which is where the current target is positioned, and mod it with the nums len, the number of elements, in case if you are having to go back around. I believe that should, because this will be negative if the right target position is actually to the left, but the mod should wrap it around nicely. Then the left target position is equal to position list at position list index minus 1. Mod that entire thing with the length of position list. Again, generally speaking, you should just look to the left, but if that makes you go if position list index is 0, you get down to -1. Modding it will make it go back to n-1. So that should be fine. And the left steps, left number of steps you have to take, is the query minus the left target position. Generally speaking, you'd expect the left target position to have a smaller position than the query, but in the case where you have to wrap back around, this will become negative. You mod it with nums_len, and you should be fine. And answer at the Q index should equal the minimum between the right steps versus the left steps. And then we just, and then we return answer. Damn it. Oh, my bad. Other test cases? No? Nope, that's an answer. I think I back it. I don't know. I mean, I've already got an accepted solution, so I don't think this will affect my... Yippee! There we go. Look at that. Improvement year by year. Marginal improvement. What was that problem I was thinking of? It was the one... Let me go to my YouTube, because I think it's easier to find stuff, because I wrote a big description. This one. It was like another range kind of... How do I just look at the information? Creating buckets to turn non-contiguous sequences into contiguous subarrays. I don't know if that's exactly the same. I can't really remember what I did in this problem, but it was this idea of like, you know, I care about an array of like 3s, for example, but they're not contiguous, so I need to combine them. So using a hash table to do that is nice. Anyway, it doesn't matter. What did I do last time? Because I feel like my submission last time was quite, much slower. Whoa, I did binary search? Ah, whoa, that's crazy. So I didn't have the idea of making the second structure. So I used binary search to find the index, like where that position was. Because I knew that the position lists, each value in the hash table, they're sorted. So you could use binary search. Why am I using like a gajillion for, why is there a magic number randomly? I think this was a point in my life where I couldn't write binary search very well. What is happening? I can't, what? This looks fine, yeah. Length of positions -1. Why are you doing it like that? I guess it's just a way of like invalidating or something. I'm so confused. I don't know what's happening. There's a ×3 in here for some reason. Alright, yeah, never look at this ever again. This is way better. Clearly, even runtime alone kind of shows that. I mean, I'm using binary search, there's a log_n term in there. But you can do it in linear time. This is linear, right? Because you construct this in linear time, and then you construct this... Oh, I guess it's... Depends on which one's longer. O of n plus q. Whichever one's longer. But everything, each query gets processed in constant time, and each number for the pre-processing gets processed in constant time. So there you go. Hopefully that made sense. I think it would have made sense by the end. I think I talked over and over again enough for it to eventually make sense, but each individual explanation was not good enough. That's all right. Yeah, okay, we're good.